and thank you for joining us today. We've got a very special guest on. This is our fourth time, our fourth go around, and I think it just keeps getting better. We're joined by Shubhi Jain, and I want to give you a big thanks for coming and talking with us. We originally chatted, I think it was at the end of last year, and we talked about what you've been doing at SurveyMonkey with the ML platform there and how you set things up. So when we started this MLOps community, I thought it would be great to chat with you again and get your opinion on just MLOps and ML platforms in general, because I knew you would have good information to share and knowledge to pass on to the community. So um, let's go ahead and jump right into it. We we kind of, or I've been usually starting from the beginning and asking people, our guests, how they got into technology, where that came from. So if you could just tell us, Shubi, a few things about how you started into tech and where it's gone from there.
That sounds great. Thanks so much, Demetrios, for having me on here today. And yeah, that's a great question to start us off. So I grew up in the Bay Area, so super fortunate to be surrounded by tech. My family, like my parents, a bunch of my cousins, a bunch of my friends, kind of grew up in this area as well, where we started working in tech very early on. And you're really surrounded by it in the Bay Area. You see it everywhere. You drive down some highways. You take any you're talking with folks, and tech is everywhere. And so how I really got started on this journey for myself is back in school, I started attending some hackathons. So, you know, it was a really great space for me to learn new technologies, learn what this building culture is like, what things you can really build using software. And from there, I never really stopped. I went and studied computer science in college, did my undergrad and my bachelor's at Caltech. Then from there, I ended up joining a very small startup working as an analytics engineer, where I did a lot of what you would call classical data engineering stuff. But given that it was a startup and we were just 20 people, I ended up doing quite a bit of machine learning and machine learning infrastructure as well. From there, I'm at my current role where I work at SurveyMonkey as a machine learning engineer. But along the way, I've done a bunch of passion projects and side projects, some consulting work where I've had the opportunity to help build out various aspects of ML platforms or help build out for a variety of customers and clients, both within the financial space as well as in the tech space. So, kind of going and looking at various organizations that are at different stages within their journey of tech as well as data science and machine learning, I think has been really eye opening. And I've had the opportunity to understand what really I can do to support that organization to do well for whatever they're really looking to do at that time. And it's been exciting, and I'm really looking forward to seeing what comes next. This is a rapidly changing field. You learn some new things every single day, every single week. So it's been great.
Completely. And along those lines, when you joined SurveyMonkey, had they already had something in place for an ML platform, or was that starting from scratch? Where did that come from?
That's a great question. So I joined about 3 months after we decided as a team that, oh yeah, we need to have like a platform in place. So at that time, what we had was essentially microservices for each use case. So whenever we wanted to develop a new machine learning use case, some data scientist or ML engineer would start developing a model. And once we were ready with that model, we went and said, okay, let's productionize it. Like if we need something real time, let's wrap it around in a microservice. Let's Dockerize it and let's deploy it. And at SurveyMonkey, given that we're a pretty old software company, we've been around since '99. We have pretty standard processes for setting up microservices. That's not very hard, but around April of 2018 is when we realized, hey, there are some unique requirements for our machine learning microservices that other teams don't really have to deal with. And that's where we decided, hey, we need to have a platform for this. We have some special requirements that allow us to look at this in a greater scope and realize there are a lot of different aspects like retraining models, feedback pipelines, where data is coming in from, various things like that that made us sit back and say, oh yeah, we need something else besides the process that we have set up right now.
And so when you were looking at what you needed, how did you go through this build versus buy process? Because I know a lot of companies are looking at, should we get a third party or should we jump on it and start to build it ourselves?
Yeah, always the first question you want to ask. I think um, we also asked ourselves the same question too. And I think what really helped us figure out whether we should build or buy is we turn to our team. We say like, hey, if we had the ideal platform where every problem that we're facing today and maybe for the foreseeable future is taken care of, what would that look like? What would the requirements for that look like? And so we had, I remember, something like a multi-day brainstorming session where we're all just sitting down and writing like, okay, in the ideal world, um, I'd break this down into we broke it down into three groups or three pillars, and I actually realized that these three pillars aligns really closely with what Phil had talked about last week on this meetup as well, which is we talked about the data side, then we talked about the services and the serving side, and then last we talked about the management side. And although those three pillars are not the exact same words that say Phil had chosen, I think his were data, software, and governance. Um, I think they match up pretty closely though. And for each of those, we ended up defining, okay, what are our requirements? For data, we need some way for our data scientists to easily find data within our organization. We need some way for us to reduce training serving skew. We need real-time live updates for our machine learning features. Then on the serving side, we needed ways to have feedback pipelines be built out either real time or in a slower batch moving way. We needed to record every single prediction that took place or inference across all of our models, as well as be able to handle that within our A/B testing and experimental platform. Um, and then on the management side, being able to manage all versions of new models that are coming out, all model projects, and then all sorts of data that's coming through this. And so as we started writing everything down, we said, okay, there is not one platform that can do all of this for us. And then it becomes a question of do we matching things? Well, given the way that development moves in this kind of space, how it's so rapid, we might choose that we're going to go with this platform today for the data side, but then tomorrow we might see it's not compatible with our upgrades on the serving side or on the management side. And so that's where we sat back and said, okay, I think it makes sense to build here. And we had the expertise in house, which was really great for us to convert some of our general software engineers into machine learning engineers and data scientists that could help us build this out from within. And we did some hiring, of course, but I think largely we did have great experience within the organization.
And I'm wondering, how big was the team that embarked on this journey?
It's a great question. I think so. We had like 4 or 5 data scientists and 5 to 6 machine learning engineers. And just to be really specific, the difference between these two groups of people are data scientists and our team are primarily responsible for developing machine learning models, whereas machine learning engineers are primarily responsible for developing machine learning services. So all the deployment side of things. Sometimes there'll be some overlap because people have some expertise as well. And just because as projects grow and expand, there could be something there. But largely speaking, that's the breakdown. And actually, since then, we haven't grown too much. I want to say we've probably added 1 or 2 more data scientists or 1 or 2 more machine learning engineers, but our output capacity has definitely grown to the point where we had a handful of ML use cases back in 2018, and that's exploded to the point where we're, nearing the 30s and 40s, where
Wow.
it would take us on the order of, say, 6 to 8 months to have one use case from inception or like ideation to out there in production. But now it's on the order of like, say, a month where we can get something out there and get the ball rolling, which is really great.
Yeah, so what the work you put in paid off, sounds like.
Oh yeah, yeah, and there's definitely room for improvement. It's an iterative process, but we're really happy to see how we've been able to really accelerate our velocity when it comes to all these kinds of projects.
Completely. So, last question before we jump into the actual frameworks and whatever, all of the infrastructure and how you're doing it.
Hmm.
As far as upkeep goes,
Yeah.
how does that play out? And how is it the machine learning engineers that are doing that? And how much of your time or the machine learning engineer's time is spent on just making sure everything runs properly?
So yeah, I think that's definitely really important to know, especially for like teams that may not have like dedicated platform oriented teams, or they don't want to have folks that are dedicated necessarily to like manage the platform. I want to say that in terms of upkeep, there's not a lot because we want our platform to work for us. It's really, the whole game is automate, automate, automate. I think though that there is some time that's dedicated to adding new features or new capabilities to the platform, and that's really an iterative process. And each we like to break apart our development cycles into quarters and then sprints. So whatever our quarterly goals are, like okay, we're going to break this up into 2 week sprints. But for each quarter, we generally have like a couple of goals, like how are we going to increase the capabilities of our platform today? Does that mean that we're going to add in a completely new component? Does that mean just a new some new upgrades here or there that are small? And so upkeep time can be relative based off of what our goals are for that quarter and what we're looking to do. If we have, in general, like fewer machine learning use cases that are new to the organization or that we have made promises to, say, product managers or other product teams that are a bit, we have fewer of those, then we can maybe dedicate some more time to upgrades in our platform. And really, we're looking less on the maintenance side and more on the improved capability side. Um, so I think on maintenance, I want to say it hovers between 5 to 10% of our engineers and data scientists' time, which is around the time that we roughly would spend on any service for that matter. Just, if anything goes down, all right, yeah, let's take a look. What's up with that, or anything along those lines. But generally, we look to automate things as
So now let's get into the nitty gritty.
yeah,
Can you give us an overview of what you're working with and how it works?
definitely. I can definitely walk through a bit of an overview here. So I I like to break this apart into, those 3 areas. There's that data side, that services side, and then the management side. And on our data side, what we've developed here, so just to give you a bit of background, like back in 2018, what we would be doing is we had a data warehouse that was managed by our data engineering team. They would be in charge of developing the ETL that would do like a prod copy of all of our databases into, um, our data warehouse. And something that's unique about SurveyMonkey is that we're a hybrid platform. So some of our stuff is on premise and some of our stuff is in the cloud. And we're actually in the midst of a transition of moving everything to the cloud and putting that on AWS for us. However, given we're a pretty old company, we went with on premise many years ago, and we stuck by that for quite some time. And so all of our data that was used for machine learning model training and development would sit in our data warehouses, and our data scientists would cull through these hundreds of tables, be really familiar with which data sits where, what kind of quality checks they have to run, what kind of validation, in order for them to get the raw training set. And that would take a really long time, sometimes on the order of months. And then on the serving side, our data would be looking like, okay, we know what tables this came from in training. But sometimes we have already set up some services that serve us this table, the data from these tables already. So really, we should be using these microservices, because our engineering teams have worked hard for us to deliver that sort of data in a nice, clean format at certain latency SLAs and all those kinds of things. So we would go through a strenuous process of mapping, okay, you got so and so feature from this data warehouse table. So really this maps to this service, and it's this feature, but really got altered here somewhere. So we need to do some engineering on top of it. And then we have some really lengthy data validation process to make sure, okay, yeah, that's the same feature. We're not having some training serving skew that takes place. And to do that for every single model, for every single feature was a pain. And we did it wrong so many times before we got it right. So we knew this wasn't the right way to go. And our solution to this was developing a machine learning feature store where we wanted to have essentially a one-stop shop for all machine learning data. And we realized that we were essentially serving two use cases here. One is this kind of bulk training use case where we wanted data to be made available for all of our users that use the SurveyMonkey platform, but still in an easy enough way that maps to the use case of our machine learning projects. So I gave a talk about actually our machine learning feature store at the O'Reilly Strata Data Conference last month, and I can show like a quick slide maybe so that it makes a bit more sense of
Yeah, great.
what this kind of looks like.
And that's something that I remember when we talked last. You were telling me, yeah, we're almost done with the feature store.
Cool. So the way that we thought about this ML feature store was, actually I'll show a different slide first. We took a good hard look at our data patterns that existed within our organization, and we found a relationship that, we had several one-to-many or one-to-one relationships that existed between our data and the entities between them. And then we also realized that our data scientists wanted point-in-time window views into our data as well. So let me break down what that means. So if I'm, say, like Airbnb, I might be developing machine learning models that are centered around our guests or our hosts. And these entities have all their relevant feature data about them. But then they might have some more in-depth data about, say, a guest can have many stays, a host can have many homes. And these one-to-many relationships are then aggregated in view with respect to a certain entity. And so at the end of the day, what data scientists really want is a super flat table that contains all the information about that entity and all aggregated other information about their sub entities or higher level entities. And they're, at the end of the day, they also want this information with respect to a certain time. So how did, that data look like for a certain user on January 1st, 2016? I should be able to know that so that I can develop, say, like a conversion model or a churn model about this. And so we thought, okay, we really need to have a feature store that serves this use case for our training purposes. And ultimately, the structure that we were able to come up with that was super simple for our data scientists to use and work with and easy for us to develop enough was creating a flat table for each entity where we have each entity ID broken down by each day. So each day's data and then all the features specific to that entity. I know this is like a really wide flat table, it has hundreds of features. And this made it super easy for our data scientists to get up and running with any use case that they needed to work on. And so this machine learning feature store sits within, we use AWS for all of this. So we leverage EMR to do a lot of our data processing. We leverage AWS Athena as our final tables for entity tables for our data scientists to send requests to. And it's backed by S3. So all the data is actually just sitting in S3 for us. And It's really exciting to see that work in real life. And then from there, we had, so that's really our batch use case. But then I talked about like our serving issues, right? So at the same time, we have a streaming architecture that reads off of our application logs from all of our services and creates a one-to-one mapping between the features that are in our feature store here and what spills off of our application logs. In real time, these values are then updated in a similar exact same structure feature store that can be read in, you know, at a single layer, at a single line. So if I want to know what is the data for a specific entity on a specific date, I hit my real-time feature store for that, and my services hit that real-time feature store, and the latency on that is, just a few milliseconds. And so really, I'm able to get single line reads super fast for my real-time feature store, but I'm able to do my bulk reads against my bulk feature store as a data scientist whenever I want, again, at a pretty fast speed. So I know that was a lot of information. So I can maybe take a quick pause for you to ask some questions there.
That was great. And I
Yeah.
think this may be a good moment for us to open it up to everyone else that's in the chat right now. If anyone has a question that they want to ask Shubhi, feel free to unmute yourself and fire away.
I have a question. Can you hear me?
Yeah.
Yeah, I can hear you, Alessandro.
Oh, hi. Yeah, this is Alessandro Maoggi from California as well. I have a question. So you mentioned that in the build versus buy choice, you end up with the determination was better to build. That, I imagine, was done some time ago. I wonder if today you would have different considerations because there have been so much new services that are offered by these third party like AWS, Google, and so on.
Yeah, no, that's a great question, Alessandro. I think that there might have been some aspects of our platform that we might have decided to just buy. I agree with you, but probably smaller aspects, not like a huge data aspect or a huge serving aspect or management right out of the box. And the reason for that is even now, 2 years later, we have the ability to look back and say, oh, should we have done anything different? And each time we do our retrospectives and ask ourselves this question, what we end up realizing is it doesn't end up being two things. It doesn't end up being super compatible with the rest of our architecture that we've developed. It ends up being like you need to buy into the whole thing, and then you're limited by the capabilities of what you buy into. At least in the ML space, since this is moving so quickly, what ends up being released as a buy option takes some time. And then the second thing is more of a SurveyMonkey limitation is whenever we're working with anything, we often work with our infrastructure teams to make sure, okay, are we good from a security perspective? Are we good from any support or expertise perspective? Do we need to learn anything substantially new from an infrastructure team if anything were to go down? Because if anything were to go down, we're the first line of defense. Given we're a consumer platform, we have hundreds of thousands of people using our platform every day. It's very important for us that things don't go down. Uptime really matters. But the second line of defense is our infrastructure team. They get paged next. And if they don't have expertise or they aren't able to learn the expertise, learn the tools effectively to be able to support us, that doesn't help us either because we don't have good backup in those scenarios. And so really the first thing is realizing that we would be locked into certain things. And then the second thing is a bit more practical of we didn't have the ability to have a good support from like a DevOps perspective in terms of like if things were to go down or in terms of just uptime and such.
Thank you.
I'm seeing a few questions in the chat. One from DC asking, did you handle versioning bit temporarily? And if so, how did you express consistency requirements for end users?
Yeah, great question, DC. I So in terms of versioning, so our ML feature store, essentially we version by day, and we realize that's not necessarily the most granular versioning that is possible. Technically speaking, we can do it by every single change that's taken place across for each user, going back in time. But we really looked at what was really needed by our use cases, and a day versioning, like versioning for every single day, was more than good enough for our use cases and teams. We didn't have any issues with anything like that. So we're like, okay, we know something greater is possible, but what do we really need? We can get away with day-based versioning, and so we did. And then in terms of when we need to version our training data for our machine learning models, so our machine learning models, they actually would have their own, they would read from our feature store to develop their training sets, and then each training set would be versioned based off of whatever data science would be versioned by timestamp, based off of what the data scientist wants to use. So models are rarely developed by saying like, oh, these are the features in the feature store and this is the date that I want things for, and that's it. We actually do have a separate process of like, okay, yeah, this was the exact data that was used to train version 3 of this model, and it's sitting here in S3. It's time locked. If we need to go retrain version 3 of the model because of some corruption in the model artifacts, we can actually go do that, and we're pretty happy with how that works. And so that allows us to have that consistency with our model artifacts and model versions themselves. Let me know, DC, if that doesn't answer your question fully.
Yeah, I think that that's awesome.
Yeah, and then we just have one more question in the chat. I'll read it out loud for everyone that's just listening in. Does the feature store also store updated results of other ML models or just plain features from the DWH?
Great question. So when we first started, it was just plain features because that was our phase 1. We just wanted to get the ball rolling. Now it does have updated results of other ML models, and that's really useful because, as we know, the inputs of some models are the outputs of other models, and so that all of our use cases really function. And the way this really works is we have, and this gets into more of the feedback pipeline side of things, but we have feedback pipelines that are set up to output results of models into other bases within our data warehouse, or spit out things into our log stream that we can then put directly into our data warehouse, and then it gets read into our ML feature store. So different ways of making that happen. And the reason for both of these things is sometimes we need real-time feedback, and sometimes we're okay with slower moving feedback, where the actual true results or true values of inferences of ML models, we end up getting those true values same days later. Like, does a user convert? Well, we might end up finding that answer, say 30 days later. But is a user a spam user? Oh, we can actually find that out like super fast. So based off of when we can find out the true values of things, that's when the values are updated and made available within our ML feature store.
Cool, very cool. And since you're giving us a few use cases, can you go into a bit more depth on other use cases that you've had? And
Sure. Should we talk maybe more on, just to like keep the ball rolling, let's talk more about use cases and then maybe related to the serving side of things?
yeah, perfect.
Yeah. So we developed essentially a machine learning services gateway that acts as our one place for all machine learning services. So essentially, if you want to call any ML model, you hit our machine learning service gateway. You let us know which model you're looking to hit. And if there's any A/B testing you're looking to do specific to model versions and such, you can pass that in. And then we pass in the data needed for that model to make an inference. And what we want to do is make it super easy for our partner services to integrate with us. So when I say pass in the data needed to make an inference, I don't mean all of the raw features that are needed to make a model inference. I might mean, oh, they just give us the user ID or the survey ID. And then from there, we know for each model what features are needed. We go hit our real-time feature store, get those features, and then we have essentially model project pods, which are just clusters of nodes that are all running the same Docker image or various different versions of Docker images if we're doing proper versioning and A/B testing. And then they've received all the grab that in, we go hit those nodes, get our inference back, and then return the result to our whoever called our service.
So can you just repeat that last part? I think you may have broken up a little bit.
Oh, sure thing. So basically, we have like a high-level gateway. We receive all requests. We go hit our real-time feature store, grab our features. Then, based off of whatever the API parameter inputs are of which model we're looking to hit and which version, we go hit. We have an Nginx routing layer in between that helps us route based off of these params which nodes we should be hitting to make our inference. We go make our inference, and it travels back up our path to then return our results to our users. And so there's essentially a load balancer that sits right at our gateway layer, and then we have a router that sits at right below our gateway to route which nodes we should be hitting to make our inference. And we're able to do this now both synchronously and asynchronously, because some of our models are super heavy and say they might take on the order of seconds, but our partners want to be able to receive a result, or at least know that they made the right call, made the right request pretty quickly. And so what ends up taking place there is asynchronously will return like, hey, yeah, we got your request. Here's your ID. Ping us whenever you need to display results to the user, and then we can go ahead and do that. And so we're able to overcome our and the reason why we did this is we had some hurdles on the infrastructure side. We couldn't support some models that needed GPUs to run very quickly, and this was mainly due to like say our infrastructure team. We couldn't get those GPU enabled clusters or nodes, and so as a result, we're running some things on CPUs. They're a bit slower, but we're able to still meet our requirements for delivering really quick results to our users. And a use case that kind of demonstrates synchronous versus asynchronous is we have a machine learning model feature called SurveyMonkey Genius. So this is a feature that sits on the create side of our SurveyMonkey platform. So when you're creating a survey, all good. When we're creating a survey on our platform, we want to help our users create optimal surveys. So we provide them with an estimated completion rate, estimated completion time, and some recommendations for how they can better their survey so that it's more likely to be completed. And so these are backed by a couple of different machine learning models, but we want the result to appear real time as the user is creating their survey so that they can make the changes to their survey almost immediately. And so this is the case of, say, synchronous inference architecture, or synchronous inference call. But then there's a use case of asynchronous inference call, say when we're doing some heavy analysis upon our surveys and want to return some outputs on, say, the sentiments of every response for the survey that you're looking at. You can get millions of responses on your survey. Getting the sentiment for everything can take quite a while. So in those cases, we're like, okay, yeah, let's use our asynchronous architecture. It'll take us a couple of minutes for us to get you, the overall distribution of sentiments and such things like that. And so let's use our asynchronous architecture, and our users are okay with that, and we've been able to deliver on that for them as well in an efficient manner without bogging down our infrastructure too much.
That's so cool. Thanks for breaking that down.
Yeah.
So Carthique in the chat was asking a question that I was actually also going to ask about the inference architecture. And does it run on Kubernetes?
Great question. So it is not for us because we, um, whenever we're looking to add in any new tool or technology to our stack at SurveyMonkey, we like to go through, we have to go through set processes. So while we would like to be using Kubernetes down the line, it just hasn't gone through that process of approval by security, approval by infra, making sure we have all the knowledge that we need to support it. Um, Essentially, we given we're a public company and we have um, we're a consumer facing platform, we need to make sure we have all our lines of defense there and all our checkboxes ticked. So what we end up using instead is Ansible, which we have been using for many years at SurveyMonkey, and it works well for our inference architecture.
That's great. And Ryan's got a great chat, or a great question in the chat, I should say. He's asking if you can go more into the tech of the async architecture and if it's closely related to the synchronous architecture, or is it a totally different solution?
Yeah, it has layers of similarity, Ryan. And so I would say the aspect of making a request, our gateway, our routing, that all remains the same. I think the additional layer of complexity comes in essentially what we use to inform our clients, like, hey, your request has a response that's ready, or for sometimes to even pass in a request to us, is we use a message bus. That's our SurveyMonkey wide message bus. We created a topic for ourselves, and that allows us to do passing around of requests and responses in an asynchronous manner effectively. And that's essentially our main differentiator, I would say, between our async and synchronous architecture. And there's some things also getting more into the nitty gritty about like priority of requests and prioritization queues and different things like that. But that's super specific. And for each use case, we end up realizing, oh, we need a new capability. How can we architect our asynchronous architecture to work for this use case? Plus, everything else exists already. And we like to be driven by use cases rather than engineering the whole thing that we can think of and then trying to make it work, because otherwise we get bogged down by all these other things.
So DC had another question in here. It's do you run any human tests? I.e., how long does it take a human to add a feature, get it flowing through to the endpoint?
Yeah, definitely, always. Whenever we add in a new capability, or whenever we're just like, hey, let's see how have things improved. So like at least once a quarter, we'll be looking to say like, okay, we have a new use case, new machine learning model that we want to help develop. Go through the whole flow by yourself. How does it look? How long did it take you? Let's record it all. We have it all documented. We know how long things took. We know where the pain points exist. Um, and that serves as information for what we can do better next time and what improvements we can continue to make to our platform. Or it acts as, say, a learning experience for people that are onboarding onto our platform as well. And so both things. And these human tests we always have to run to make sure that our platform is working to serve our data scientists and ML engineers well. And we're really expanding to other teams now, helping to democratize machine learning within the greater SurveyMonkey engineering org.
I think that could be a nice segue into talking about how you're doing monitoring with the machine learning models. And I know that there's a few things to keep in mind when you're monitoring machine learning models. You have to just make sure that everything's working properly, the system is up, but then you
Mm-hmm.
also want to make sure that your models are doing what they said they were going to do. And so are you using a third party just to monitor the system like Datadog or Instana or whatever it is? And then is that all in-house also, or are you also did you build that out, and how did you go about that?
Yeah, great question. So yeah, when we look at monitoring, we look at essentially three things, I would say. One is the service monitoring. So just like you're monitoring any service. Second thing is input data monitoring. So monitoring like what kind of data is coming into your machine learning models. And then third thing is like prediction slash like true value monitoring. And so on the service side, we do use some third-party tools to help us out. And this is used across our entire organization. We use New Relic. I was thinking to make sure that I'm allowed to say it, and we are. So yeah, we use New Relic, which allows us to handle all the monitoring on terms of like service side of things. And it's really similar to Datadog. I've used Datadog in the past, and it works quite the same.
Yeah,
and
actually,
then yeah, go ahead.
Dan Sullivan from New Relic is going to be on here in about a month, so I'll let him know. That's
Yeah,
very cool.
definitely. Yeah, we're big supporters of New Relic, and it's worked really well for us, so we're really happy about that. And then on the input data monitoring side of things, what we're essentially doing is we look through our log stream. We log all of our input data going into our machine learning models. So that can be logged to our application logs. So that would be coming through our log stream then. So, you know, we have different log streams for different use cases. So Kafka or our message bus or different other things like that. And then the second place where we might log things is every prediction is also logged into a prediction DB. So it sits in a database. We can query against it real time, allows us to do any sorts of like analysis, check on data drift, various things like that. And so because it gets logged to our log stream, we can develop some dashboards that allow us to look into data drift. What is our data distribution looking like for all of our features for this specific model? What is our prediction distribution looking like for this specific model, for each version of our model that's sitting out there? How are our A/B test results looking like? We can go also map these to true values later on because our machine learning service contain feedback endpoint. So if we can get the feedback real time, we do ask our clients, hey, hit our feedback endpoint. Let us know what the real value was. And that allows us to then map, oh yeah, we made this inference. This was the input data. This was the true value. This is how well our model is performing. And that gives us a real-time view into our model performance. In some use cases, we don't have that. And that's where, because we're logging everything to this table, whenever we do get that feedback, we ask our partners to also log that feedback into a table of sorts. And so we can set up some feedback pipelines that essentially map these inferences to true values. We can then get some results of how well our model is performing. Usually it's like daily or weekly views. And then we just post it into a Slack channel. So whoever this model pertains to, say our product managers, our clients, us, the ones that worked on the models themselves, are aware of, oh yeah, this past week we saw some downtick in performance. Probably we have to go look into this and see like what's going on, or then we can maybe kick off an auto retrain process to just auto retrain our model if our performance dipped below a certain threshold. And so we have all these systems working in tandem with each other that allow us to monitor all three aspects effectively.
Very cool. And Waleed, I see your question. I just wanted to ask one more about that auto retrain because last week when Phil was on, he made the case for this idea of good practice being just to auto retrain, but he wasn't sure it was so worth it in some to most use cases, or what he had seen with certain companies, it wasn't needed. Do you have auto retraining going on, or is that something that is not necessary? How does that work with you guys?
So I agree with Phil as well. I think there are some use cases where you do not need it. And I think that's the same thing for us. There are some use cases where we do enable it and some use cases where we do not. However, we whether we enable auto retrain or not is one thing, but still being able to auto retrain is, I think, another thing. All of our models, if we need to retrain our models on fresh data, we can. We can just click a button and it'll go retrain. And the reason for that is because if anything were to get corrupted, if anything were, we realize like, oh, we lost our model artifact, our whole like repository of our model artifacts went down, we know we can go and do it again, and we're confident in that. And that is just, our backup processes. We want to make sure everything is good there. And I think often we think like, oh yeah, everything's in the cloud, it's safe. But S3 goes down too, AWS goes down too, and we like to just have our backups there for those keys, for those that less than 1% of the time when things go wrong. And it also allows us to have a level of accountability of making sure like, oh, we did what we did during training and we can reproduce it. And the reproducibility aspect makes sure that if someone is leaving the company and someone new is joining, it makes sense to them what went on here, and they can get the exact same model artifact once again, so it can be used in a case. So a couple of different smaller reasons there that force us to have auto retrain available still there, but it's still only enabled for certain use cases where we see data drift occurring, or where we see that, oh yeah, our performance is varying over time. Yeah.
Yeah, completely. It makes sense. So Waleed had a question here in the chat. He was wondering, he says, I would like to understand more the role of Ansible in your infrastructure. Could you please elaborate on how it's used and how your on-prem infrastructure looks like?
Yeah, it's a great question, Waleed. So Ansible is used for orchestration for us. It's used for setting up, like, we have hundreds of microservices. SurveyMonkey, each microservice has specific Docker images they want, specific setup for node flavors, like what kind of instance you're dealing with, different things like that. So Ansible orchestrates the setup for each specific node relative to which service it's going to fit under. And that's essentially what we use it for. There isn't much, there isn't any real, and that's a limitation of our on-prem infrastructure. As we move to AWS, and some of our services are moving over there, and some of our use cases are moving over there, that's where we can take the benefit of what AWS gives us there. Our on-prem infra, I can't talk too much more about than what I've already said, unfortunately. Yeah, I apologize for that, but we rely upon Ansible to set up our nodes and instances that sit in there.
Perfect. And Alessandro was asking, do you have use cases that involve personal identifiable information? If you do, how do you handle that?
Yeah, great question, Alessandro. We do a lot of we are HIPAA compliant because many hospitals or healthcare professionals use SurveyMonkey. We also integrate with a lot of enterprises that provide us PII info, and so PII data, and so we need to be able to work with that. And so the way that works is our real-time feature store is set up in a secure manner that only specific services can access it. And it does contain the PII data, since sometimes we do use PII data during inference time, and that's known to our users. It's an opt-in thing where users have to opt into it. However, for training, no PII data is available. We can't make that accessible for training ever. So you cannot train on any PII data. It can be anonymized in certain use cases, depending upon the use case. And we have an entire governance process set up that I'm not responsible for, but we make sure to abide by it at each point to make sure that we are working there effectively. And I think the PII data that we use in the real-time cases are also, like, we do have the ability to be able to go back in and delete it if needed, and the various other processes that have been set up for to abide by like the data governance practices that we need to fulfill as a SurveyMonkey org.
Yeah, that makes sense. JH has a question here about the line between the machine learning engineer and data scientist. He's wondering, creating, managing model artifacts, using repository for this, model versioning, retraining. Is this the role of a ML engineer or a data scientist? How do ML engineers and data scientists work together? And when does the ML engineer take over? Or are they continuously working together? Because data scientists aren't often keen on software development or versioning.
Yeah, no, it's a great question. I think each organization works differently. So I can talk specifically from SurveyMonkey is few years ago, it used to be like, oh yeah, data scientists do all the model development. They give us the model artifact, and then they're like, okay, here you go, handoff. That did not work very well for us in the long run. And since then, we work together in tandem from the very beginning. Um, and that allows our data scientists to pick up on some software development. It allows our ML engineers to understand the model at a very, very low level. So that makes sure that we can know from the get-go, like, oh, actually, we don't have this data available in our feature store real time. Like it only gets populated once a day. So like, are you okay with that? Is that fine? And our data scientists know this, like the requirements or the limitations up front, or like, oh yeah, we can't support a 15 layer neural net. We can only really support 10 layer ones at the moment. So, whatever you're looking to do, we can't do that. And because those conversations are happening earlier on, our data scientists know what the restrictions are. We know what the restrictions are. And from there on, we can really make sure that we don't have any like blockers that we didn't foresee kind of appearing. And as a result, to be specific, data scientists still are probably the leads on the model development, and ML engineers are more so the leads on the productionizing aspects. But there is definitely some crossover and more crossover that happens over time. And I would say that over time, I'd say I've gotten way more adept on the data science side of stuff, and our data scientists have become way more adept also on the software engineering side. They really know what's going on. And if anything were to happen to our services, I'm sure they'd be able to, chip in and make sure things are running smoothly.
Great. All right. So we got 2 minutes left. I want to ask you one final question, but before I do, what's the best way to connect with you if anyone wants to continue the conversation?
Oh yeah, I would say LinkedIn's probably the easiest. It's the thing I look at most frequently. I do have a Twitter and all, but I don't. I feel like I end up using it all too much. So yeah.
Perfect. So LinkedIn, we'll put that in the follow-up email. And my last question to part is, can you talk to us just quickly about some obstacles that you faced when you were building the platform? Something that you thought in the beginning was going to be easy and it wasn't, or just something that came out of nowhere and blindsided you?
I think we knew this was going to be hard, but it was still super hard when we did it, which was just defining the requirements and like making sure we stick to it. At the end of the day, we were trying to create something that we didn't have too many examples to follow. Like what we would often do is we would talk to other ML teams at other organizations, like, oh, hey, what are you guys doing? Or what are you doing? And that helped us figure out like, oh, what was a manageable task or manageable thing we could take on? Or sometimes they would talk about their own obstacles or nightmares that let us know like, oh, what's possible or not possible, or what should we really try to do. But I still think at the end of the day, it was really the scoping, like figuring out like what can we take on, what can we do, is this possible, what do we really need, and I think we spent a lot of months doing that and having a lot of back and forths on all aspects about that. The we still probably in terms of our iterations probably still have that, but I think that was probably the biggest obstacle. Another one was definitely just expertise. We ended up using a lot of tools that we weren't necessarily familiar with initially, so it was a learning process for us. Like we hadn't used PySpark heavily on like say our feature store side of things. Um, Learning that was tough. It's definitely a learning curve there. Um, I would say that those are probably our two large obstacles that were there.
Perfect. Thanks so much, Shubhi, and connect with him on LinkedIn. Thank you, everybody, for joining us. This has been an awesome conversation. You all asked some amazing questions. I'll send up a follow-up email, and I look forward to seeing you. We're doing this every week, so please come join us next week. See y'all later. Have a great night. Stay safe out there.
Thanks, Demetrius. Yeah, stay safe.